So, let's see if I can get this thing to give me my smart ink. It says I do. Go very, very quickly. All right, so yeah, my room had to be sanitized earlier today. Before some of the weeds and smells bad. So that's not what's on the desk. What's on the desk is not good.
I still mask.
Yeah. Does anybody want the paper version of this? So your desks are trying to dry off. Yes. They are the same ones that are in Canvas. The assignment is in Canvas. I have it in paper. I think most of you are going to want to do this one in paper. Yes, if you did not do the timeline, you wanted this version. You did not do the timeline, you can still carry it in today. I'm in the process. I don't know if I put the grades in for this class. I think I may have gotten to this class. My class was sanitized during my cut period, so there was my chance to try to get caught up on Yes, I know the desks are a little wet because they're drying. You really need a paper towel. I have some. All right. The next thing I'm going to give you, and I'm going to make sure everybody has a hard copy of this, although this is also in Canvas. You have a PDF of a periodic table. We are going to be using this all year long. Now, the one that I linked to you is this one, and it is an updated version that has all 118 elements that are listed. There, yes, because the one that's on the wall is older than I am. This one, they actually named and gave the information out for the last of the, oh, I forgot to do it, sorry. The last of the elements just a couple of years ago. Everybody needs a periodic table. We're going to be using this, starting off with the opener. You need to know how to do this thing. This thing tells you answers. Do you want a paper version of the notes, please? No, you're good. And if your vision is like mine and you forget glasses, then you can zoom in on the one that's linked in Canvas. I know it's hard to read some of these numbers. And so there's 118 periodic table elements. We're going to look at the simplest one, which is hydrogen. So on the top left-hand corner, you see the H all by itself. Most elements start, not all, most elements start with the first or maybe first two letters that are found in the element's name. Hydrogen is the very first element, so its symbol is just an H. And inside this periodic table block, please work for me, computer, good. So inside this, now on this one, H is in the center. We have a 1 up here at the top left-hand block. We have 1.008 down here on the bottom. And then it says 1A up on the top, outside of the box. This tells you just about everything that you need to know about the normal hydrogen atom. Now, the one that the question's about is not a normal hydrogen atom, and I'm going to show you how you can tell the difference. A normal hydrogen atom has 1 proton on it. That's it. So that top number, whether it's in the center of the block or it's the top left in the block, this tells you how many protons are in the element because that is what controls what the element is. You change the protons, you don't have that element anymore. And then in the one that I gave you, this is an average of all of the different types of hydrogen that exist. Most of them don't have anything else in the nucleus. But since you see this 0.008, that means that there are some species of hydrogen, which are called nuclides, which we'll get to those tomorrow, that actually have neutrons in them. Not many, because this is closer to 1. Now, the difference between today's assignment and the numbers that are on here is you are not using this bottom number from your periodic table. Yes, you are using this top number, because this tells you the number of protons, and this tells you the number of electrons of a natural atom. I have to tell you the mass so that you can figure out if it has neutrons or not. This is how I can tell you the mass. Hydrogen 2 is going to have the same number of protons as regular hydrogen. How many protons did I say regular hydrogen has? 1. So my proton, which is how I abbreviate proton, it has 1. Now I said that regular neutral atoms have the same number of electrons. So how many electrons does it have? 1. On today's assignment, don't try to work it early. On today's assignment, the atomic number is also going to be the number of protons and electrons. That's it. It's the same number. Now the neutrons, which have no charge, that is the difference between the mass that I tell you and the atomic number. And what is 2 minus 1? Regular hydrogen doesn't have any neutrons. This is called deuterium. Do any of you happen to know that deuterium was responsible for us creating, specifically in the United States, back in the 50s? Yeah, the original stuff that was used to create atomic bombs. Now, was this what was actually in the bombs that were dropped? No. But the studying of deuterium, is that what led to the development of the atomic bomb? Yes. And what happened, if I draw this atom out, we had 1 proton, we have 1 neutron that has no charge, and then we have our electron ring. That's supposed to be, no, that's not. It overlaps my thing. Okay. So I have 1 electron, which is negative. And when we talk about splitting the atom, the original research that we did that led to the bombs and us bombing Japan was we literally split that proton and that neutron off from each other in the nucleus, and it gives off massive amounts of energy. That is why deuterium is talked about so much. In fact, if you've ever heard the term heavy water, the original stuff that they used to figure this out was water with this type of hydrogen, which was twice as heavy as regular hydrogen because it had twice the mass in the nucleus. This is where that phrase comes from. Y'all, I had in 4th period, even with all the fits that my smartboard gives me, they had no problems with what we did, and a lot of them actually turned in the assignment before the end of class. If you do not understand where I am getting numbers from as we're taking a look at this periodic table, I need to fix it. This is the first major skill that will never, ever, ever go away in this class. You will be using this periodic table for the rest of the year. And I believe next week, we're going to color code one of these. So if you want your own colored pencils, because mine are all in that bin, you probably want to get your own set of matte pencils. Doesn't have to be like the big crazy set of 64 or anything, just a normal set of match colors. And that should be next week sometime. I haven't done my lesson plans for next week. I'm still working on this week. All right, atomic structure. You can double check and pay attention to this. You guys have this carbon atom. And it says on yours that it does have 6 protons and it does have 6 neutrons. The red ones on mine are the protons. And the white ones on here that don't have anything in them are the neutral neutrons. I know that on the one that you guys have, like the 6 was in the corner and then carbon was underneath the symbol, but this is still the atomic number. This is still the average mass, and this is still its number of valence electrons. The other things that I know on here, I have 2 different rings, which are energy shells. Remember, I know that they're really clouds, but we draw the rings because Bohr's model is much easier for us to draw. And I have a total of 6 electrons, where there are 2 on the inside shell, and then to get up to 6, there are 4 on the outside shell. Now, the first shell can only hold 2, and then it's at maximum capacity, and then it starts filling the next one out, like putting layers of icing on something. So if there's 2 on the inside, then there's 1, 2, 3, 4, which is this number up here. You probably do not know your Roman numerals. So the one that I printed out for you and that I have on Canvas, if you find carbon and go above it, it does say Roman numeral 4A, but it also tells it in regular old numbers that we're used to. That means that everything in this group has got 4 electrons on the outside shell, and they all talk the same way. because this is how carbon talks. Not like us, like a puzzle piece. It has 4 bits. It either wants to get rid of all 4 bits or it wants to gain 4 more new bits to be full. Just depends. What's carbon going to do? That's the part I need to teach you, is how they talk to each other. And I can show you the long way, which is algebra, and I can show you the short way, which is sort of like cheating. You just got to remember one extra step. But we're getting everything out of our periodic table. And so the next one, you guys, you don't have this image, I don't think, but your questions, you're fill in the blank. The center of the atom is called a nucleus. The nucleus has all of the mass. Protons are worth 1, and neutrons are worth 1. AMU stands for atomic mass unit. It's just how we measure mass in an atom. Atomic mass unit. Each one of the ones in the nucleus is worth a function of 1. No decimals, just 1. Then your other major part, besides the nucleus, is where the electrons are. And electrons are super teeny tiny, and they're so small that they really don't affect the mass of the atom. This is the heavy part of the atom. This looks like it's 4 and 5, which is 9. This is a beryllium atom. And I know that because there are 4 protons, there are 4 electrons, so I know that there are none hiding in the background, which means the atomic number is 4, which is this guy right here. I just have to teach you how to read the periodic table before we can do all the math. Because all we're doing right now is adding and subtracting with this. So protons are worth 1, neutrons are worth 1. They're both found in the nucleus, which is the heavy part of the atom, which is on here. The average is the bottom number. The protons and the electrons is the top number. Neutrons is the difference between them. So the other part is where the electrons are. Specifically, it's a cloud. This is more of Schrodinger's model, where you have a 3-dimensional bubble. It just so happens that this is showing the S clouds. So they really could be anywhere. These two could be anywhere in this light blue. 1, 2, 3, 4, 5. This is 7. This is, this is nitrogen. These 5 valence electrons could be anywhere within that darker blue section. They really don't move on a ring. We just draw the rings because it's easier for us to draw it that way. So your electron clouds, which are on the outside of the nucleus, have the negative bits. The electron's negative charge is exactly opposite the proton's positive charge, but it's 1/1,800th the size. But it carries the same but opposite charge. Electrons is what we've learned to harness for electricity. When they get really upset and they jump from one energy shell to another, they give off light, which we call a photon. Just depends on how angry that electron is. The angrier it is, the faster it wants to jump shells, the easier it produces light. So protons and neutrons are worth 1 AMU. Electrons are 1/1,800. 1/2,000 essentially. I need to do attendance, and you guys are Ethan, Benson, Nathaniel. I need to check online. Oh, this is the wrong period. That was in the right class. Okay, and then Fademan should be online. One, I do not see. Really Grayson, Asher, Marisol, Trevor, Douglas, Tucker, George is not in here anymore. Justin and Hayden. And you're not quarantined anymore, so I need to change that. They sent so many people home earlier today. Well done with this one? I don't want to check my online attendance until I've written everything on the board, since I successfully have smartly pinged this tab. The atomic number is the top number inside the block. Like I said, on the one I printed out for you, it's on the top left-hand corner. That tells you how many protons, period, end of story, for each element, and each element is different. It's the number of protons that makes the element, and it's always equal to that top number, not the Roman numeral on the top, inside the block. If it's a regular atom, which is what we're dealing with today, that's also the number of electrons, because atoms are neutral. Ions are not neutral. We're not even close to that yet. So your atomic number, so if I do sulfur, which is the S, atomic number is 16, so it has 16 protons and it has 16 electrons. If I look at silver, which is Ag, silver comes from a Greek word, which is why it's not Si, that's silicon. Silver, atomic number is 47, so it has 47 protons and it has 47 electrons. It's really that simple. But right now, that top number is the positives and the negatives. What you have to be able to calculate is the neutrals, the neutrons. It's literally subtracting. Can't remember if I have another button on here and I lost my version of the notes. Notes are really, really, really short. I want to make sure that you guys can analyze this periodic table. Y'all should not be on your phones. Y'all put them away. You're writing on paper. And so carbon, I don't think you guys have this image on yours, but it's the note down on the bottom. It says, how many protons does a carbon atom have? So looking at, even though we just did it at the beginning, if the atomic number is 6, how many protons does it have? 6, which means how many electrons does it have? 6. Now, I have to tell you which carbon it is to know specifically does it have 6, 7, or 8 neutrons in it. Because there's 3 different types, there's 3 different species of carbon. Most carbon has a mass of 12. Some of the carbon has a mass of 13, and the stuff that we use to see how old mummies are from Egypt has 8. That's carbon 14. But all carbon, no matter what, has 6 protons. I don't care what the species we call a nuclide. I always call them isotopes. Isotopes are the older version of this phrase. Nuclides are the newer version of this. It's just a newer phrase. It means the same thing. Isotopes or nuclides, everything's the same, but they have different numbers of neutrons. So the natural state, which is carbon 12, has 6 neutrons because it's a mass of 12 in the center. If 6 of them are already protons, 12 minus 6, not the decimal number, the whole number I give you, which would be 12, minus the atomic number is the number of neutrons. Carbon 13, if 6 of them are already protons, then 7 of them are neutrons. And carbon 14, the one that we use to date things that have died, that haven't been dead a very long time, because you can't do that with dinosaurs, but we do it with mummies, has 14 in the nucleus, of which 6 of them are protons, 8 of them must be neutrons. We're not dealing with things that are charged, we are dealing with things that have different numbers of neutrons first. So on back, mass number, it's the heavy part, it's the nucleus, it's the number of protons plus the number of neutrons. Each one has a mass of 1. Technically, a neutron is an electron's amount bigger because it's a fused proton and neutron. When we had the Big Bang, just a few billion years ago, more like 15, when nothing was traveling faster than the speed of light and it started to slow down, once it slowed down below the speed of light, we had the first particles that were popping out, your protons and your electrons. And the first thing that they made was hydrogen. And then towards the end of the hot Big Bang, we had protons and neutrons that fused and they formed a mutation called a neutron. Then we had helium. And then things went from there. We're talking way, 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 way back at the beginning of the universe. But each one's worth 1 because the difference between a proton and a neutron is so negligible that we don't measure it. The atomic mass, the weight, the decimal number that we're not dealing with yet, that's an average of all of the isotopes. Since it's an average, You have numbers after the decimal. A mass number is a whole number for a specific type of that element. The average is the decimal of all of them. I know in the past I've asked my chemistry students to calculate the average atomic mass of something. We use beans. I don't know if we're going to get to that or not. We will see. Now we are going to take a look at filling out that chart. I'm going to do 2 more than what's on yours. And then we're going to take a look at the first one on the homework paper, and you guys have the periods to try to work them out. Like I said, in 4th, they went through it pretty quick. Anybody still need this one? You guys aren't filling out anywhere near the stuff that I have to do. All right, so you guys have the top 2. Neat periodic table. All I know is I have 16 protons, and I know that my total mass number is 33. Now, I can't write on that right column. That's outside of my writing area, so that's the same here, the atomic mass or the mass number, because it's going to be a whole number. How do I know what element, if it's got 16 protons is? How do you know it's sulfur? You're right. It's, right, the protons has to equal the atomic number. So this is sulfur. The British spell it S-U-L-P-H-U-R. We don't, because we're American English. And its symbol's a capital S. I know if it has 16 protons, the atomic number is 16. And I also know it has 16 electrons. Now, I'm going to rewrite my mass number over here. So if my total center of my atom is 33, and 16 of them are protons, how many of them are neutrons? The total is 33, 16 of them are positives. How many are neutrals? 17. You just subtract the 2. There's really not that much to it. Okay, but you need to use the mass number that I give you. They're whole numbers, not that decimal off the periodic table. You can't use that number yet. I haven't taught you what that really means yet. All right, so the next one, I know that the atomic number is 19. So what element is this? That's potassium. Which is the letter K, not P, that's phosphorus. This comes from a Greek word, kalium. So I know that if that's true, I've got 19 protons and I've got 19 electrons. So what's its mass? Add the protons and the neutrons. Nope, no, not 39. Use a calculator if you have to. Add the protons and the neutrons. I think I heard it. 41. Now, if I look on here, most potassium has a mass of 39. This is a specific species of potassium that has a mass of 41. Which, like I said, I've always called them isotopes. They like using the term nuclide here. It's the same thing, different numbers of neutrons. Next one, I know the mass is 27. No, you don't have this one. I know the mass is 27, and of that mass, 14 of them are neutrons. So how in the world are you going to figure this one out? You know the total center, and you know of that center, 14 of them are neutrons. Can you figure out how many protons you have?
No.
You know the entire nucleus, of which 14 of them are neutrons. It's only neutrons and protons that are in the nucleus. So if 14 of them are in there, how many more do you need to add up to 27? 13 of them. So if you know the protons, what else do you know? You know the electrons and you know the atomic number. So now what element is this? 13 is aluminum. The British put an extra I in there. They call it aluminium. I have no idea why, but they do. So as I'm writing all the way in red, I hate red. And then carbon. Now, I know carbon has an atomic number of 6. And I know its symbol is C, not Ca. Ca is calcium. Protons are 6. Also, the electrons are 6. And since I can't write it over there on the side. Oh, no. Yeah, no, that's right. So the mass, protons plus neutrons, this is not carbon 12. It's carbon, this is carbon 14. The The name and the mass is how we write out an isotope. Just has a different number of neutrons. Y'all are literally just doing this. Now, before I check online, is there a question where I was getting these numbers from? Okay, let me turn the light on, let me double check online, and let me double check assignments. Now, if you did not do well on that test, and I think I still have some people that need to take said test, for retesting purposes, we need to figure out what happened. Okay, so attendance. Let me freeze this. Let me make sure they don't have questions online, and let me see if her quarantined babies have tabbed on. Okay, so I see Jessica. Okay, I'm going to stop this recording.